Right, we're going to look at inverse functions. Notation for the inverse of f of x is f minus 1 of x. You have seen this notation before. If you think about it on your calculator, when you do shift sign above the sin x, it looks like that on your calculator. Because you're doing the inverse of sin x, you're undoing sine of x. So the inverse performs the reverse of f of x and vice versa. So f of x performs the reverse of the inverse. So if f of x is x plus 2, the inverse of f of x is equal to x minus 2. So it takes you back to where you started. If g of x is 5x, the inverse of g of x is x divided by 5, and the inverse of h, if you want to undo timesing by 4 and take away 3, then the first thing we're going to have to do is add 3 on and then divide by 4. So if you do a function followed by the inverse, which will be that way round, so I'm applying the function followed by the inverse, that will equal x. So if I add 2 and then minus 2, it just takes me back to where I started. And if you do the inverse followed by the function, that will also equal x. So it undoes the function, the inverse. We need the inverse to be a function. And if you remember, functions are many to one and one-to-one mappings. So if f of x is a many-to-one mapping, so you've got more than one value of x mapping onto a value of y, then, so it's going to be looking something like that. That's your f of x. Then the inverse would be one to many, because it has to take you back to where you started from. But then the inverse wouldn't be a function, because one to many mappings are not functions. So for a function to have an inverse, it must be a one-to-one mapping. That's quite important. So it must be a one-to-one mapping. Otherwise, the inverse would be one to many, and then it wouldn't be a function. So if necessary, you can restrict the domain in order to achieve a one-to-one mapping. So if necessary, this can be achieved got my wobbly board, by restricting the domain. So as an example, if I have f of x equals x squared plus 3, and we can have x, remember the reals, so there's no restriction on x. Then that's just x squared moved up by 3. Put any value of x in. This is a many-to-one mapping, so we've got more than one value of x, just to demonstrate, being mapped to the same value of y. So this is many-to-one. So to make this one-to-one, you can't have any overlaps. So you can't have, if you think about it, you can't have a minimum or a maximum turning point, because then you'll have more than one value of x mapping to the same value of y. So in order to make this one-to-one, we can just look at these values on the curve here instead. And so if we let f of x equal x squared plus 3 for x being greater than or equal to 0, then that creates a one-to-one mapping. You can do a shaded circle to show that the 0 is included on x, and an open circle if it isn't. So that there is 3. So that is now a one-to-one mapping. And just to remind you, the range of this is the values it takes on the y-axis. And so the range is that f of x is greater than or equal to 3. So in order to find an inverse, first of all you need to sort your domain out and make sure you've got one-to-one mapping. I need to check if I'm going to run out of time. I'm going to leave that there and pop the next bit on the next video, because I think my phone's not going to like it otherwise.